So what I want to talk about is focus on CEMS and what we're seeing in the U.S. And sometimes we don't have a lot of answers, but we're seeing really strange results every now and then. And like the paper that Uniper put together, all this study, it really fits together. And so I think PM monitoring, depending on where you're at and where you're looking at it, is pretty common. And I think it's one of those things I like sharing what we see. And like I said, we don't necessarily have answers, but I like talking about it, and maybe we'll each learn something in the process. So I'm going to talk on several topics today. I'll just touch on them. We'll see how I do with time. Actually, I thought I had 20 minutes, not 15. So real quick, this is sort of my view of the calibration curve for a CEMS. There's only two things that matter: the reference method and the monitor output. That's it. Nothing else matters, but there's a lot of things that affect both of those in all the testing. The little bubbles to the right in yellow are mainly operational issues, and the blue ones are more stack testing and testing related issues. Real quick, so Jeff mentioned our match rule this morning. The mercury and air toxics standards. Originally in 2012, the big thing is in 2023 it was proposed updates, and the biggest update that fits with this conference or this topic is about 30% of the coal-fired units in the U.S. were using continuous emission monitors for PM. 30%. The other options were do quarterly stack testing, or do what's called a CPMS, which was just a reduced version of the PM CEMS. But the proposal in 2023, and it ultimately became law in 2024, required that everybody go to PM CEMS. This was going to be, if you were a PM CEMS manufacturer, I'm sure you were drooling over this. It was going to be a really large market. And then earlier this year, with our new administration, they have proposed to repeal those updates and take us back to where we were in 2012. So it still is a proposal, hasn't been acted on, but a lot of utilities are sort of planning on it going through. And one of those companies is Southern Company. I wanted to mention them here because they started earlier this year doing a big internal research program. They're funding it. They brought in multiple PM CEMS vendors, but they wanted to try to test the results of different particle sizes in relation to the monitors. This work, I think 1 to 2 weeks of work was put in on it. There was going to be several more phases to it. Now it's being sort of shelved, and no more work is probably being done on it. I talked to the gentleman who was in charge of it, and he said that it's above him, and there's not money being put into it right now. So that's where we are. But I wanted to mention that it leads into, for me, particle size is the ultimate thing for PM CEMS. What does it see? What does it not see? What is your normal particle size distribution? I won't spend a lot of time on this. This is a PM CEMS curve for US EPA's performance for PS11. Normally you have your as-found data and then your elevated data. It becomes a full statistical curve, and that seems to be important. At first I didn't think it was necessary, but since we've been doing this for almost 16 years, I think it is very necessary. Dan's charts showed the high particle count being around 0.3 microns, but the mass was driven by the larger particle size. And I think that's what this data represents. So your mass to analyze a response is more important, at least from my perspective, as you get closer to your permitted limit. So now I'm going to show you some real PS11 curves. And by the way, if every curve in the US looked like this, I probably wouldn't be standing here talking to you. It's a beautiful curve, right? Now let's go on to some others. So the low concentration PM causes a lot of problems. So I mentioned EPA proposed a parametric monitoring system, CPMS, which took 3 points, usually the way the rule was written, as found, and drawing a linear relationship back through instrument 0. Well, some of the low data points have a spread in them, and they don't even represent anything near what a real PM-SIMS curve looks like. So when I was here 2 years ago, and David gave a presentation from part of this study and basically said that these real low particle numbers, particle counts, particle size, have a different response to mass ratio. It's like, okay, that starts to make sense. That's what we're seeing. So that's why it makes more sense to have these data points higher up, because you're either defeating your ESP baghouse, or in our case, we're feeding it in, taking it from one of those control devices, but it's more representative of an upset condition. I wanted to show this where they took a 0, this testing data took two 0 points, and these were the as-found data points, and I drew a curve through that, and you can still see that even it doesn't have as representative a curve. But here's where particle size, to me, I've been looking at this for the last 6 or 8 years, and when you move into wet scrubber systems, that's why I'm really interested in next paper, you've got a whole different beast. So this particular system, it almost looks like there's two curves.